Hello. Today we're going to talk about Docker with RunAI, and we're going to run through some Jupyter examples. So let's get started. So first, we're going to introduce Docker. We're going to talk about what Docker is, why you should use Docker, and what you need to actually run Docker. Then we're going to talk about the Docker image and how to run Docker images with RunAI. And finally, we're going to talk about the Docker file and layers. Next, we're going to go through an example of how to use a Docker image with RunAI using Jupyter. And we'll run through some key concepts, and then we'll talk about how to mount an NFS onto a Jupyter job. Then we're going to talk about running Docker images with non-interactive jobs. And finally, we're going to go through some closing notes, some general Docker tips, and some stuff that we should be aware of. Okay, let's dig in. So what is Docker? Well, Docker is a way to create these images. And images have an operating system and software installed on them. And images can be run on any hardware as containers. So typically, this is how your compute resources look like. Your software is installed directly on the hardware, and your apps run using that software. Now, with Docker, you can containerize your specific libraries and software that are required for your app into a sort of image. And these images can be run on any hardware. And so why should we use Docker? Right. So let's go through an example. Let's imagine that user 1 has some code and it requires CUDA Toolkit 11.2 and Python 3.7. User 2 has different code, but he requires CUDA Toolkit 11.7 and Python 3.9, and user 3 requires 11.5 and Python 3.8. Now, they could just install all of these versions of the software on a machine and just manually manage it, or they could each create an image with the software that they need installed on it, and then they can just run the image inside a container on any hardware with the Docker engine running. And so what do you need to use Docker? Well, one, you need an image repository. I use Docker Hub. It is the most popular repository. It's kind of like GitHub for Docker images, and it's free. So definitely register with Docker Hub. And then you also need the Docker software. So I like to use Docker Desktop, and you can find the instructions online. So you just got to get that set up as well. And now how do we actually create a Docker image? Well, one, we have to make sure that the Docker Desktop or whatever Docker engine you are is running. And next, you're going to need a dedicated folder for your Docker image. And within that folder, there needs to be this file called Dockerfile inside of the folder. We will discuss the Dockerfile more in depth later. And then you're going to open up a terminal. You want to make sure that your terminal is in that image directory, and you want to make sure that the Docker file is inside that folder as well. And then you're going to go ahead and just build your image. And so this is what mine would look like. Basically, we're telling Docker to build, and we're tagging the image. This is going to be the image name, and it's going to be your Docker Hub username. In my case, it's Jonathan Cosme / the name of the image, colon, and then the version number followed by a space and a dot. That's all. And then finally, after we've built our image, we're just going to push it to the repo. And it's this command where we run Docker image push and the tag of our image. And that's it. You've got the image built. And so how to use a Docker image with RunAI? Well, it's really easy because we require it for everything. And there is a field called image. And you would just put your image tag here in the UI. If you're using the CLI, you would use the -i argument or flag to pass in that argument. Now let's talk about the Docker file itself. So what is a Docker file? It is a simple text file. It's just a text file, and it tells Docker how to build the image. So this is an example. Now don't pay attention to the stuff on the left. Just focus on the words that are in all caps at the beginning of each line. And so these are the 3 basic commands. So the from command specifies the what's called base image, which is just a starting point. Run is the command that you'll basically use to install your software. You could also run any other Linux command that you would like within your image while you're building it. And then CMD specifies a default command for the image to run once it's in the container and running. So if you don't specify a command, then it's just going to run this. But if you do specify a command, it's going to run your command, but not this command. Yes, these are case sensitive, and they must always be in caps. And there's a lot more, and a full list and explanation can be found online. So in this particular image, we are starting off with this image, a base image that has Conda and Mamba pre-installed. And then I'm just installing OpenSSH server. And then I'm going to use Mamba here, which is a version of Conda that's written in C++, so it's much faster. And we're going to use that to install TensorFlow. And then finally, I'm just going to tell the image to print hello world if no command is given to it. And now let's talk about layers. So looking at our Docker file, every time a Dockerfile command is used, a layer is created. And so this image, our image, has at least 4 layers. Now keep in mind that the base image also has layers. And so our layers are going to be built on top of the layers of that base image. And so essentially, the total number of layers is however many layers are in the base image plus our layers, which is 3. Now, all else equal, more layers makes the image larger. And as a general rule, we want images to be small. And so we have to pay attention how we create our layers. So if we take a look at these two examples, these actually install the same software, but you'll notice that on the left, we have 6 layers, and on the right, we have only 3 layers. So this would be the better way to do this. You wouldn't want to install your package, each individual package in its own layer. You would just consolidate those into one layer and install all of the libraries that you need within this one layer. And so the purpose when you're creating layers, it should accomplish a specific goal or task rather than installing one software package. And now we're going to talk about caching. So this is very important. Docker will cache layers that have not changed. The reason it does this is to make building faster. And so if you change a layer, that layer is going to have to be rebuilt, but also all the layers after it will also need to be rebuilt. And so you want to structure your layers so that the most often changed layers are at the bottom. Let's take a look at this. We've got 2 ways of building the exact same image. In this one, we're going to put the CMD line before we install our software, whereas here we're going to put it at the very end. And so let's say we want to change that CMD from hello world to run AI is great. Now the net effect on this first image is that because this image, this layer has changed, the installation layer, which comes after it, also has to be rebuilt, which means that the image now has to reinstall all of these packages. Whereas in the bottom one, only this layer has been changed, but not the previous layers. So it doesn't have to reconstruct these layers. It's already created this layer and it doesn't need to run. And so just updating this one layer is much faster. Basically, you would definitely want to build your Docker file this way. And now let's go ahead and run an image through Run AI, particularly a Jupyter image. So let's go to review some key concepts first. And the first one is think of your software and storage as like 2 separate things, right? Not combined. They're their own things, right? And second, Run AI is going to take care of the hardware, so you don't have to worry about that. Now, your software, you're going to put into containers by using Docker, and your code and your data, you're going to keep on your storage space. Typically, this is an NFS. And so the idea is that you're going to mount your NFS in your Docker image and then run a script that's stored inside the NFS. Now, Jupyter is a tool that's commonly used by many data scientists. In our examples, we're going to use an official image, which can be pulled with a tag Jupyter/base notebook. And so if we were to run this image on Run AI, we would open up the UI, we would select interactive over here. We would just put Jupyter/base notebook in the image. And we'd also have to make sure that our Jupyter notebook flag is set, it's toggled on, and then we could submit the job. We're going to wait for the status to change to running, and then we can go ahead and connect. And one thing we're going to notice is that if we go to the work directory, it's going to be empty, which makes sense because we've just loaded the image by itself and we've done nothing beyond that. Now, when we want to mount an NFS, right, our shared folder, our storage, we're going to start with the same options as before. Select interactive, put in the image, and toggle the Jupyter Notebook button. But this time we're going to mount the NFS folder to the work directory inside of the Jupyter image. And so under storage, we're going to go to volume, and we're going to add a volume. In the source path, we're going to put our NFS directory. In my case, it's this. And then in the target path, we're going to put the work directory location of the Jupyter image. And what this is going to do is basically mount all of the content of this folder, and we're going to be able to access it in this folder. And so we do the same thing. We wait for the status to go to running and we connect. And if we go to our work directory, we'll notice that all of our folders and all of our files are here. And so I can go ahead and get working. I can create new scripts. I can create new projects. I can test out different things and so on and so forth. Now, what about running Docker images with non-interactive jobs, right? Maybe I would just want to run a training job. I don't actually need to use the Jupyter UI. And so let's say I had a script called MyScript, and under the work directory, it's going to be under my projects folder, under the projects folder, and under that, it will be the my projects subfolder. And finally, we've got my script. And it's a simple script. This is what it looks like. It's just going to print this. This is my script.py file under the my projects folder. That's all it's going to do. So how would we do this? In order to run the script using the image, we're going to first select training job. We're going to insert that Jupyter/base notebook in the image. We're going to mount our NFS. And here is where the new thing comes in. We're going to add a command under container definition here. And this is the command. So basically, we're telling Conda to run some argument inside its base environment. And that is going to be, we're going to use Python to run our script. And notice that I put the full path of the mounted folder within the work directory here. And so once we go ahead and submit that, we're going to wait for the status to change to succeeded. And then if we go over to our logs, we're going to see that it ran successfully and that the script printed. This is the myscript.py file under the my project folder. And just before we leave, I want to go over a couple of things. So some general Docker tips, in addition to everything we talked about. You want to try to use an official Docker image as a base image just because they're more stable. You want to try to use a specific version. The more specific, the better. If no version is specified, Docker is just going to take the latest version, which might contain new software and it might break your image. So that's always a concern. And then finally, if you're starting with a raw operating system image, select an image with a lean distribution. So Ubuntu is a very popular distribution, but there's a lot of software that you actually don't need to run your container. And so you might want to use something like Alpine, which is much smaller, has all the software that you need to run your Docker container successfully, but doesn't have all that other unnecessary software that Ubuntu has. Be aware, and this is very important. Only the content of the folder containing your NFS mount is going to be saved and persist. So this means that everything else, all the other files that were created during the job session, will be gone forever once the job finishes. And if you didn't mount anything at all, then no files that you create are going to be kept. So you want to make sure that you mount your folder and that you're saving and working with the files within the location of that mounted NFS. And then as you're running the image, as you're interacting with it, any software changes made while the job is running will not be saved. So if I've got Jupyter up, I've used the image to open up Jupyter Lab, and I use the apt install or conda mamba install create, those things will be gone as soon as I stop running the job. So in order to permanently do software changes, I have to update the Docker file, rebuild it, and then repush it to Docker Hub. And that's all. Thank you so much. I hope you enjoyed our presentation.